The Mechanical Comprehension (MC) module of the Asvab exam tests your understanding of mechanical principles, structural support, and material properties. The questions gauge your knowledge of simple machines, compound machines, mechanical motion, and fluid dynamics. Although it might all sound a little complicated, you will find that you encounter these concepts every day, and the math skills needed are no more complicated than those you have already learned in earlier chapters. The MC module on the CAT Asvab contains 16 questions, the MET Asvab contains 25 questions, which you will need to answer in 20 minutes. To achieve your 70%, you need to answer 11 questions correctly. To achieve 80%, you need to answer 13 questions correctly. As in the Electronics Information (EI) module, much of the MC module is sheer knowledge recollection. Although you can guess some of the questions correctly without knowing the underlying principles behind the question. Most of the questions are ones for which you need to know the applicable principles and apply the correlating formulas to get the right answer. The good news is that you have a little more time per question than you did in the EI module. However, you still need to move as quickly as you can through the questions. What is mechanics? Mechanics is the branch of physical science that deals with objects in motion, the forces acting on those objects to cause motion, and the universal laws that govern the motion. The same laws that dictate the motion of the solar system also determine the motion of an airplane, or a baseball in flight, and even define molecular behavior. Mechanical motion describes the application and observation of how the universal laws of motion apply to our everyday experiences in everything from opening a door to loading a ship's cargo. Before you can understand how and why an object moves, you must understand that all motion is relative to a reference point. Position indicates the location of an object relative to that reference point. When an object located in one position changes positions, it has moved. When an object has a continuous change of position, the object is in motion. The moving object might be moving differently in relation to its reference, or not at all in relation. For example, a book lying on a desk is seemingly motionless, and in reference to the desk and the objects around it, it is motionless. However, it actually partakes in at least 4 kinds of other motion. Earth's rotation about its axis. Earth's revolution about the Sun. The motion of the solar system. The motion of the galaxy through space. Therefore, technically, the book is in motion, and motion itself is relative to the conditions of the situation. The next step is to understand the fundamental rules of motion that apply to any situation. Forces of motion. In the 17th century, Sir Isaac Newton first introduced the 3 fundamental laws relating particle and object motion to applied forces. Mechanical engineers today still use those laws. First law of motion: an object at rest tends to remain at rest unless acted upon by an external force. An object in motion tends to remain in motion at the same speed and in the same direction unless acted upon by an external force. The tendency of matter to resist changes in motion is inertia, which is directly related to the mass of an object. Second law of motion: the acceleration of an object acted upon by a force is directly related to the strength of the force and inversely related to the object's mass. The acceleration occurs in the direction of the force. Put simply, an object's acceleration is determined by the strength of force that is making it move, and an object's mass is the resistance to that acceleration. Third law of motion: for every action, there is an equal and opposite reaction. This means that all forces operate in pairs. Fully understanding this law is fundamental to grasping concepts such as equilibrium and resistance. A force F is any effort that can translate, push or pull, or rotate an object to cause movement. This movement depends on the strength of the force and on the distance, d, away from the object. It is expressed in foot-pounds, foot-pound, and is stated as follows. Moment, torque, equals, force, distance. Or M equals Fd. In mechanics, several physical properties, vector, scalar, and tensor, affect the physical properties of materials and how they respond to factors such as heat, movement, loads, and other stressors. Vectors and vector quantities. In mechanics, a vector is defined as a force or influence on an object. A vector quantity has at least two forces at work against the object to cause movement, and is usually represented with an arrow. The length of the arrow, drawn to a convenient scale, represents the magnitude, force or speed, and the head of the arrow represents the direction the object is moving. The vector quantities are as follows: velocity, force, momentum, spin, displacement. Scalar quantities. A scalar quantity has only one force at work against the object. These physical quantities have magnitude, amount or force, but no direction. For example, if a force is applied to an object, then the only consideration is the effect of that effort. If the object is unaffected, then no work has been done. The scalar quantities are as follows: speed, work, length, area, mass, energy, electric charge. Tensors. A tensor is a vector quantity that describes three or more forces at work against an object. In mechanics, a tensor refers to the stress-strain relationship for materials whose measurable values are not consistent along different axes. In the affected materials, stress in one direction creates strains in other directions. Tensor quantities are an important measurement in gauging elasticity. Motion and mechanical laws. To measure motion, you must be able to describe it. Several terms are helpful in describing motion, and we discuss those terms in the following sections. Speed. Because motion involves changing positions, you can determine how far an object has moved if you know the length of the path along which it traveled. Speed is the rate of motion, the distance traveled in a given amount of time. The more distance an object covers in a certain amount of time, the greater its speed. You calculate speed by dividing the distance traveled by the time elapsed. Speed equals distance time. Or S equals dt. You can calculate two forms of speed. Average speed is the overall distance that an object travels divided by the rate of travel, or an average of the speed, even though the object will travel at the average speed only occasionally. Instantaneous speed is the speed of a moving object at any given instant in the path. A speedometer is one device used to measure instantaneous speed.